Standard deviation is a measure that is used to quantify the amount of variation or dispersion of a set of data values. A standard deviation close to zero indicates that the data points tend to be very close to the mean of the set, while a high standard deviation indicates that the data points are spread out over a wider range of values. The representation for standard deviation is represented by the Greek letter sigma. The formula for a standard deviation of a set of data values is sigma equals the square root of the first data value minus the mean, quantity squared, plus the second data value minus the mean, quantity squared, plus the third data value minus the mean, quantity squared, and so on, divided by the number of data values. All of these parentheses are essentially figuring out the difference between a data value and the mean, and then squaring it to create an area. Here's an example. Let's say I have a set of data, the values being 10, 11, 12, and 12. We can see that there are only 4 numbers, so my data set is size 4, and those numbers are close together. I've already calculated the mean and rounded it to 1 decimal place. The mean was 11.3. Using the formula, I have the standard deviation, or sigma, equals 10 minus 11.3 quantity squared plus 11 minus 11.3 quantity squared, and so on. I've simplified that, arrived at the square root of 0.69, which equals 0.83, and I also rounded that to 1 decimal point. My standard deviation is 0.8. This number is close to 0, so the data is close together, or close to the mean, which we expected since our data values were 10, 11, 12, and 12, and our mean was 11.3. Let's explore the standard deviation a little bit more. In the next lesson, you're going to explore the normal distribution. And right now, I'd like to connect that normal distribution with the standard deviation. In the normal distribution, we have a bell-shaped curve. The area under it is 1. Since all of the probabilities in a sample set or experiment would have a probability that sums to 1. The 0 represents where the mean is. To the left of the mean, we see this -1 sigma. That stands for 1 standard deviation below the mean, then 2 standard deviations below the mean, and 3 standard deviations below. If the standard deviation symbols are positive, this is said to be above the mean, which would be a data value higher than a mean. Now, if you take a look at the dark blue area and add those 34.1% together, you get about 68%. In a normal distribution, the data values that are 1 standard deviation below or 1 standard deviation above the mean usually accumulate to about 68% of the data. If we add on to that 68%, the 13.6 and the other 13.6%, we arrive at about 95%. So we say that about 95% of the data falls within 2 standard deviations of the mean. That's interpreted as from 2 standard deviations below to 2 standard deviations above the mean, 95% of the data will fall in there. And for 3 standard deviations below to 3 standard deviations above, you'll have about 99% of your data. Calculating standard deviations can be time-consuming. So I recommend that you use a calculator or technology. Here I have 2 web links that I'm going to show and illustrate. The very first one I use when I just have a list of data. So down below I have the experiment of rolling 2 die and recording their sum. The question is, what is the standard deviation? Well, here are all the possible ways that you can roll 2 die and get a sum. I've copied that data and pasted it into the website. I click Calculate, and I look over and find the correct information. I'm looking for a population standard deviation sigma. I see that my standard deviation is 2.4. So for rolling a dice, the standard deviation is 2.4. Now I could do that exact same calculation looking at its probabilities instead. So if I have data with probabilities, I'll want to use the second link. I've listed in the very first top box all of the values for x. So the different ways that you can get a sum with 2 dice is you can roll a 2, get a sum of 3, a sum of 4, and all the way up to 12. Those are all the x values. Then down below, I write all the corresponding probabilities. The chance of rolling a 2 as a sum is 1 out of 36. The chance of rolling a sum of 3 is 2 out of 36. You continue this for all of your data values. You scroll down and you tell it that you want to find the standard deviation. Right now I'm trying to figure out where they put it. There, the standard deviation is 2.4, which is exactly the same standard deviation that I arrived when I just looked at the list of the set of data, 2.4. So I can be confident that out of rolling 2 dice and recording their sum, that the standard deviation is 2.4. That's not extremely close to 0, nor is it far away, so I can say that the spread of my data is not significantly small nor significantly great.